All right, you guys, let's go ahead and get started here on lesson 5.8, and this is actually part 2. So again, part 2. And we want to go ahead and actually solve for linear word problems. And we are going to be starting off with rate of change in this case, guys. Rate of change in this case, whenever you guys hear the phrase rate of change in this case talks about the slope. We know in this case, if we're graphing something, slope in this case does equal rise over run. But in this case, whenever we're talking about rate of change, we're actually talking about the change of y over the change in x. And this is actually just based on if we're given a table in this case and we want to go ahead and find the rate of change, or we want to find slope, we will be using this formula of the change of y over the change in x. This, you do see it in science. The change talks about the difference, subtraction. And in this case, you need 2 points. You need 2 y values and 2 x values in this case in order for us to actually solve or identify the rate of change. This is y2 minus y1 over x2 minus x1. y2 and y1, those are just different y values. So we're going to go ahead and take a look at our first problem here. And in this case, in example 1, it says find the slope of the linear function defined by the table. In this case, we are given a table where we have hours worked and money earned. In this case, hours worked represents x, money earned is y. So in this case, we have for every 4 hours, we earn 54. Every 8, we earn 180, 108, 16, 216, and so on. So our goal in this case, guys, is to find the slope. So we did mention in this case, guys, that slope is rate of change. Rate of change. And in this case, we are going to be using the formula of the change of y over the change in x. Now, in this case, guys, if you are given a table, all you need in this case is actually 2 points. Any 2 points in our table, doesn't matter which one I choose as long as I have 2 points. So for example, let's say I want to choose this first one, and I want to choose the second one here. Once again, I could choose any other ones, but I'll just go ahead and use those two. Well, let's actually try this one here. Let's try this bottom one. So change of y or the change in x talks about y subtracting both of the y. So I will be starting off with the bigger one. In this case, guys, it doesn't matter which one we start off with, as long as you align the x and the y appropriately. So for example, I did do 2,430. So below that, it should be its x value. Its x as value is 180. And then minus the x value of 54, which in this case is 4. So I'm going to go ahead and bring out my calculator here. Let me go ahead and bring it out. And in this case, I'm going to go ahead and do 2,430 minus 54. And then we're going to go ahead and do 180 minus 4. Now, we're going to go ahead and divide both of those. So I have 2,376 over 176. So let's see what that gives us. 2,376 divided by 176. 76. And that, in this case, is going to give us 13.5. So rate of change in this case, or the change of y over the change in x, equals 13.5. All right, so once again, this is the rate of change. Let's do green. Rate of change in this case is going to be 13.5. Once again, if I would have chosen any other 2 points, I should still be getting the same solution. Now, in this case, looking at the next question, guys, it does say, what does the slope represent in this situation? So question here is, what does 13.5 represent in our table here? And in this case, guys, notice how in this case we did y over x. In this case, the y is represented by the money, and the x is represented by the hours worked. So in this case, slope is representing the money earned per hour. So in this case, slope is basically 13.5 or 13.50 per hour. So that's basically how much they're earning hourly. So once again, it's Y over X. Y is the money, X is the hours. So it's 13.50 an hour. All right, so that's once again finding rate of change. So let's go ahead and take a look at our next example here. And next example in this case, guys, it says, when Quinn returned from vacation, he turned the heat back on in his home. He set the temperature as high as it could be. It says Q represents the temperature in Quinn's home in degrees after T minutes. So, first off, guys, they are giving us a unit of measure. So Q in this case represents the degrees Celsius, and then T represents the minutes. All right. So two different units of measure, and we do have an equation of Q equals 15 plus 0.4 T. Now, in this case, guys, I actually want to go ahead and compare this equation here to our slope-intercept form. And we did see slope-intercept form yesterday where we have y equals mx plus b. Now, in this case, guys, we have two important values here. M in this case represents the slope. B in this case represents our starting point, which is the y-intercept. So let's just go ahead and label that there. So this is y-intercept, and this is slope. So if we base it off of this one here, guys, in this case, I could say that in the y-intercept, which in this case represents the starting point, is 15, and then in this case our rate of change would be 0.4. So that's how much it increases each minute that goes through. So first off, it says, what was the temperature when Quinn, that should be double N, returned from vacation? So in this case, guys, they're basically asking what was the temperature when Quinn got home. In this case, Quinn hasn't actually turned on the heater. So we can say in this case that time is actually 0 because he actually hasn't started the heater. So T in this case is 0. So if we want to find what Q equals in this case, what the temperature is, we're going to go ahead and substitute a 0 for T. All right, so that in case gives us Q equal to 15. Once again, 0.4 times a 0 is just 0. So it's 15 degrees Celsius. So that's our answer. Once again, it also mentioned the start, at the start, which in this case talks about our y-intercept. And a y-intercept in this case, guys, would be the 15. So that's another way we could do it. Next question in this case says, how much does the temperature increase every minute? How much is it increasing every minute? So here, they're asking us for the temperature every minute. They're actually asking us for the rate of change here. Rate of change. And in this case, guys, we did say that rate of change here equals slope. And based on the equation we have here, we know that slope is m. So in this case, slope is actually going to be the 0.4. So our rate of change is going to be 0.4 Celsius per minute. So that's how much it's increasing each minute that goes by. Once again, I just did that by looking at our equation. Once again, slope is the number that's next to the variable. And last one, guys, it says how much will the temperature increase if Quinn leaves the heat on for 20 minutes? Now, in this case, they are already telling us what the temperature, what they're going to set the temperature to. And they want us, no, actually, how many minutes they're going to set their temperature. And they want us to find the actual temperature. So they want us to find Q. And they are giving us T. T in this case is 20 minutes. So if we want to go ahead and find Q in this case, we do have to do some substitution here. So we have Q equals 15 plus 0.4 times 20. All right. Now, in this case, guys, 0.4 times 20 is actually going to be 8. So Q equals